Today we're diving into something pretty wild, an idea that might just flip the entire story of our universe on its head. You ready?
So let me ask you this. Is the universe's story a long, slow, predictable epic, or is it more like a blockbuster movie, packed with sudden, jaw-dropping plot twists? For a long time we thought we knew the answer, but what if we were wrong?
You know, the official story, the one we've been told for decades, is called the Lambda CDM model. We can just call it Lambda CDM. And look, it's been a powerhouse. It gives us this picture of a universe that evolves smoothly, gradually, no surprises. The rules were set at the beginning, and that's that.
But what if that smooth story is missing the best parts? The drama. There's a new theory bubbling up, and it suggests the cosmos isn't some gentle river. Nope. It's more like a series of massive, cascading waterfalls.
And that really gets us to the heart of it, right? It's a clash of two huge ideas. On one side, you've got the standard view, smooth, steady, nothing really changes. But on the other side, you have this new contender, CRET-Cosmos. And its idea is, well, it's pretty radical. It says the universe can have these abrupt, sudden shakeups where the laws of physics themselves can just switch on or totally change how they act.
So how is that even possible? Well, the whole idea hinges on something you've actually seen before. It's called a phase transition. It's just a fancy way of saying a system suddenly flips from one state to a completely different one.
And the best way to get your head around this is to think about water, right? As you cool it down, it's still water. It's just getting colder. But then it hits that magic number, 0 degrees Celsius, and wham! It instantly reorganizes itself into ice. It's a solid. It has a totally different structure, different properties. The change wasn't gentle at all. It was a sudden, dramatic flip.
Now take that idea and just blow it up to the scale of the entire cosmos. That's what CRET is asking. What if space-time itself? What if gravity? What if the very rulebook of the universe could do the exact same thing? What if it could just freeze?
Okay, so if these massive cosmic plot twists actually happened, they couldn't just vanish without a trace, right? They'd have to leave some clues behind. So this is where we put on our detective hats. We're going to go hunting for the evidence, the kinks in the cosmic story.
And this new theory gives us a few places to look. It points to 3 possible moments where these transitions could have happened. First, way back in the super early universe, maybe as space-time itself was first emerging. Then, much later, during what astronomers call cosmic noon, this was the universe's busiest star-making period. Maybe a new property of gravity just switched on. And then, even more recently, we might see a kind of memory effect, where cosmic structures are still feeling the aftershocks.
All right, let's get into the evidence. Clue number 1. This is all about how stuff clumps together in the universe. You know how galaxies and giant clusters of galaxies form over billions of years. So here's what's so cool about this. The standard model, it predicts that things just clump together at a nice, steady, smooth rate. But CRET says, it predicts a kink in that story. It says that before a certain point in time, the growth of all this cosmic structure was actually held back. It was suppressed. And then, boom, after a phase transition, galaxy clustering hit the accelerator. It's not a smooth ride. It's like the universe suddenly changed the cosmic speed limit.
Okay, clue number 2. This one zooms in from that huge cosmic web down to individual galaxies. And it suggests that the rulebook for how galaxies are supposed to behave might have been totally rewritten right in the middle of the game.
So here's the prediction from CRET. In the really distant past, when we look at high redshift galaxies, they seem to be playing by the standard rules. Nothing too weird. But then the universe hits a tipping point, a phase transition. And after that moment, galaxies suddenly snap to attention and start following a new, much stricter set of rules that dictate how they spin. And it's a relationship we can actually see in galaxies near us today.
And this is the real kicker. Here's a quote from the source material. LCDM cannot naturally produce a sharp transition here. See, the standard model has a really hard time explaining a sudden change like this. If everything is smooth and gradual, then the onset of these new rules should also be smooth and gradual, not like someone just flipped a switch. That switch flip is a huge piece of potential evidence for CRT.
All right, on to our third and final clue. And this one comes from one of the biggest headaches in cosmology right now. It's called the S8 tension. Now that sounds complicated, but all it really means is that there's a disagreement about how clumpy the universe is. When we measure the early universe and predict how clumpy it should be today, our numbers don't match what we actually see. It's a real puzzle.
And this is where CRET comes in with a really fascinating answer. It suggests that gravity itself had a phase transition. The idea is that gravity was actually a bit weaker in the early universe, back when the light from the cosmic microwave background, our baby picture of the universe, was released. So if scientists run their models assuming gravity has always been the same strength, well, their predictions for today end up being too clumpy. And that step-like difference between the prediction and what we really observe, that's exactly what the SA tension looks like.
So, what does this all mean? Where does it leave us? Well, we're basically looking at two completely different versions of the universe. Two radically different stories about where we came from and where we're going.
Let's just break it down. You've got the standard lambda CDM story on one side. Smooth evolution, constant physics, simple, predictable. Then you have the CRET-Cosmos, a universe full of abrupt changes, of critical tipping points, and even a kind of cosmic memory. Scientists call it hysteresis, where the past literally hangs around and influences the present. It's a much wilder picture.
But honestly, the biggest thing to take away from all this isn't just about this theory versus that theory. It's bigger than that. It's about fundamentally changing how we even look for answers out there in the cosmos.
Think about it. For decades, the big question in cosmology has been how much has the universe changed? We've been measuring rates and amounts. But this new idea forces us to ask a totally different question. When did the universe change? Suddenly, we're not just looking for smooth curves in our data. We should be hunting for the breaks, the kinks, the moments where everything suddenly shifted.
And that leaves us with one last, really profound question to chew on. Are we living in a universe of slow, steady, almost boring evolution? Or is our universe's story actually defined by a series of sudden, forgotten revolutions, these huge plot twists that completely change the nature of reality, and we're only just now learning how to listen for their echoes? The hunt for that answer, well, it's just getting started.